So, hi everyone. I'm Bruce, co-initiator of LXDAO and ETHPanda. So, welcome to today's ERC-8004 workshop. So, part of the Let's Build Trustless Agents community education series, co-hosted by LXDAO and ETHPanda. So, we are grateful for the support of the Ethereum Foundation DEI team and for sponsorship from Slowmist and Unibase, and also community support from Build Guild. So we are more than happy to have our guests, Marco and Leonard, with us to share their expertise on ERC 8004. So Marco and Leonard, could you each give us a brief introduction?
Yes, I'm Marco. I've built a bunch of companies in the past in education and Web3. The last one brought me to MetaMask, and where I'm currently leading the AI group. And my current main interest is the intersection between Web3 and AI, and especially how can we make sure that we have an AI which is user-owned at the service of people, and we have like a thriving and a community of builders which exist around that, and not just a bunch of centralized AI players.
Cool. Yeah.
Yes, hi everyone. I'm Leonard. Previously, I was co-founder and CTO of Web3 Auth, and also that's what brought me to MetaMask and Consensys. So I work on a lot of the wallet side of infrastructure side of things, and I'm also working on 8004. So yeah, like Marco said, I think it's very important for agents, to be discoverable, not censorship resistant. So I think these are all important qualities that A004 can bring. Yeah.
Cool. Yeah. Welcome. So, so today's agenda is simple. So first, after this brief introduction, we're gonna have deep dive into the standard, because as we all know that Marco is one of the author of ERC 804. So, after that, we're gonna have implementation walkthrough from technical perspective. As we both know that the reference code has been released open source today, deployed to the Sequoia test network. So we're gonna walk through that. And in the end, we're gonna have a Q&A session. So throughout the session, please drop your questions in the chat. So I'll pick it up in the end. So we will address as many as possible during the Q&A session. So with that, Michael, so the floor is yours. Feel free to share your screen and let's get started.
Yes, before jumping into the standard deep dive, I wanted to give you a super short introduction on why, more in general, I think that what we are discussing today matters. And because this is really related to how economies will evolve and look like in a few years. So we, because of increasing performance of AI model, we are more and more, I think, aware as communities that we will have AIs intermediating what we buy and sell, both for our personal lives as consumers and as producers. And this directly creates economies where AIs are players. Economies are not something new. We have some rules, we have some dynamics, we have studied them for thousands of years. And economies are really around the players that exchange signals. Some of them are public sometimes, think about prices. Some of them are private. These players need to get aware of existence of others, otherwise how can you exchange information? Then they need to contact others. This is really like a general pattern that has been always around, also before the digital era, right? And so for AIs, it's the same in the sense that AIs needs to find each other. So you have a bunch of different approaches. You can have like centralized catalogs that you query that decide what you can interact with, maybe with a rating, like the App Store. Maybe you need to give 10, 20, 30% who runs the App Store. And in the traditional economies, well, there are in the digital space some concentration of intermediation, that's for sure, but still we have the physical world that acts as a discovery mechanism, because I can really go into the street now and like meet people, talk to people, hire them. I could go to a shop, and this is not intermediated. And so the point, the general question is, how can we in the next, I don't know, 20 years, 30 years, 50 years, have a system which is not controlled by anybody? It's like the physical world. So of course you have some source of powers, you have some controls, but AI can just do stuff in a secure way. And this is even more important for AIs for a very simple reason. They can elaborate information by far faster than humans. So the fact of having like a network of information around the participants of economy, so who is around, what I think about I don't know, Leonard, what I think about a certain company, what I think about a certain AI, it's even more important because AIs will be by far more efficient than humans in aggregating thousands of entries in real time and decide what to do, just because they are better in elaborating and aggregating information. So that's the context. And ERC-8004 is a first tentative that is getting very popular in the Web3 space to enable this, leveraging smart contracts that are distributed from an architectural perspective, because they're based on a blockchain, which has, of course, nodes and validators and so on, but they are logically centralized, which is like a complex term to say that as a developer, I can just call something, which is always like that, which is an Ethereum node, for example, and I get the same result. And we are leveraging this to create registries. And the first is the identity registry, where you can list your agent. And if you list it there, it pops up in all the explorers. That's what I was referring before. That is the permissionless discovery. And then there is a second registry where you can commit, share signals on what you think about given agents. Both agents and human can participate. So I can like give a feedback on the service that I've just received. And this enable to have these public signals around reputation that become public good. And then it's up to the community, to the industry, to create all the systems that they want to create in the next years to aggregate these signals, to create value. Again, this is the infrastructure for neutral information around agents. Then when you have public signals, that's my point about open economies, it's up to economy participants to do what they want. And this is a feature, it's not a bug, it's a great feature. And finally, we have a registry which is called Validation Registry, which is a very lightweight scaffold for enabling agents to ask validation of what they do to a smart contract. And this is very compatible with the different approaches that we see builders are excited about, even if, again, it's very early, like stake secured inference. So you have somebody that checks your AI job and is staking money, and if the checker, the guardian misbehave, he could lose the stake. Or you have trusted execution environments that through T oracles confirm the attestation of the AI agent task, or some members of the communities are pushing for ZKML, which is using zero knowledge proof to prove the computation of the inference. This is still very early, but it's making interesting progress, and so it could become relevant. I will briefly now go through the tweet that we used to launch the new version, which has some like code to represent the concepts that I just went through. But then with Leonard, we will really go through the actual implementation with the actual functions that are now on chain. Last point before sharing the screen, it's very early. So I've often asked like which are the use cases. There are many use cases already. I think that the portability of agents among explorers is the most important. But let's not forget that the web took like 3 years, 2 years in terms of first use cases to become mass market. So it's very early, and so I really think that the not just the impact of this, but also how it's used from a product fit perspective will change over time, and that's what always happens when you have stuff like this. So it's fine. You should see my screen. And for the first of the 3 registry, which is the identity registry, where again you can register and give visibility to your agent so anybody can find you. It's like the global address book of agents. We opted for 721. 721 is better known as NFTs, and this makes things very easy because you can basically register your agent calling this registry, and you pass the URI where there is like the registration file with all the information about the agents. You get an agent ID, which is the token ID in the NFT lingo. You are an owner. You can also nominate operators using the standard 721. Operators are addresses that are authorized to update the agent URI for you and do some like maintenance and authorize feedback. We will see this in a second. So you can also transfer agents very easily, as you can see on the screen. And because of using NFT, this will be immediately compatible with all the NFT infra that we have built in the last few years. So it's also good. You will see visually agents with an image, a description in the marketplace and explorers. What is this file that you have seen here pointing to? So you have a type which describes the schema basically. Name, description, and image. These are the fields that are traditionally filled for NFTs. And the agent name, the agent image if you want. Description, you can also describe the feature of the agents, which are his skills, what the agent is willing to sell. In case you can also put information about prices. We decided to keep it natural language because instead of like creating data structure for pricing, because at the end of the day, the good thing of LLMs is that they're great in understanding natural language, so you can like present the agent how you want, and another LLM could understand it. Then the most important part is the list of endpoints. So 8004 really acts as a registration that gives you, again, logically centralized. You can just call a smart contract, jump on this file for each agent, and you know how the agent want to be reached. For example, the A2A agent card, the MCP endpoint. These are probably like the two most popular communication layer. And so you really see here the different layers. So 8004 is discovery and trust. We will discuss trust in a second. Then you have the communication layer, which is a different layer, which is how when you are aware of an agent, you get in touch with agent itself. And here we are really leveraging what everybody's already using. Again, MCP and A2A are the most popular, but there are a bunch of other use cases that you will find in the spec. You can also mention an ENS name if you want, a DID with a resolver that you want. In this case is a PKH, which is just a private key, but you can do what you want if you're like familiar and you want to use DIDs. You can also put a wallet. And what you will find in the spec that you haven't mentioned is that on top of 721, you can also add on-chain metadata to the agent. So this is off-chain, this is a file, right? It's a file that is linked from the blockchain. But you can add key value metadata like agent wallet also on-chain. It's very flexible. You can use the keys that you want. So all that to say that you can have a field which says explicitly what's the agent wallet on chain. So you can do like information Lego from another smart contract and like say send the money to that address, which is the wallet of the agent. Finally, the registration is the ID of identifier of the agent ID registered that we have seen earlier. This is like to provide confirmation. So the blockchain links to the file links back to the blockchain. This way you can be sure that who created the agent isn't just linking the registration file of somebody else. And finally, you can list, this is a enum, so you need to use specific fields which trust mechanisms are supported. And this is a nice segue to move to trust, the different trust models that we support. And let's start from the most straightforward, which is very close to how many of us like pick a restaurant. So you see past client feedback, you see the number of stars, and you decide what to do. And any client, any address without being registered on the registry can give a feedback to the agent. So just to say that again, the agent needs to be registered, as we have seen a second ago, while the client that gives a feedback doesn't need to. What the client need to have that's to prevent from spam attack is to have an authorization from the server saying, okay, yes, I've worked for you. I mean, it's to avoid that you give a rating to a restaurant without having had dinner there, right? And the feedback that the client can sign has the target agent ID, so who I'm rating, a score from 0 to 100, 2 custom tags that can be used by the community, by developers to add a dimension to the feedback, to the rating. These are byte 32 fields, so you can encode the string that you want. And so only the agent ID and the score are mandatory. Tag 1 and tag 2 are optional, and also the file URI, which points to where you can find like a full version of the feedback if you want to add more off-chain information. And to provide integrity and guarantee integrity of the file itself, you also have the hash version of this file. And finally, we have the, as I was saying, the authorization from the client to give a feedback. That's from the server, sorry, to give the feedback. And how do you use that? So this, again, is the function that the client can use to give a feedback to the server. And you can also use this to get directly reputation on chain, which is the last line of that you see on the screen. So in this case, basically, I'm asking the reputation of agent 22 only filtered by the opinions that Alice and Bob gave, only for tag 1 and 2. So they're optional. Like, the only mandatory field here is the agent ID I want the reputation of 22. But that's to say that you can do directly on chain from other smart contracts, call the registry and aggregate real time and have the average of reputation for some given tags and reviewers, or for a given agent. And so you can like build on top of that. And here again, you see how 2004 aims to be just a neutral information rail that you can build upon. The off-chain file that I mentioned, again, this is optional. You can skip it. You can just use on-chain information, put score, tag 1, tag 2, and that's it. You don't need to do that. But if you want to add more information, you can do that. You identify the feedback as what's the registry that you are using, the agent ID. Many fields here will be filled by the SDKs that many community builder members are working on. Again, the feedback code, the score, tag 1, tag 2, you just repeat them. And then you can also like add information using the A2A or MCP lingo. So it's that. Let's see if we also have an example. Yes, this one. So in A2A, there are important concepts like the skill, the context, and the task. So if you want your feedback to be related in terms of a dimension to any of them, you can do that here. We expect the community to also repeat the most relevant dimension in tag 1 and tag 2 again. No, it's no problem to repeat them. So I don't know if my feedback is on the skill of finding hotels, I can put this both in tag 1 and skill. While the example here is related to MCP. So for MCP, for A2A, skill, context, and task. For MCP, you have the capability. MCP, in terms of server, currently supports 3 capabilities. Tools, the most famous, and then you have prompts and resources, and you can specify exactly which tool you are giving the feedback to. And you can also add like free data structures comments. You can also add a proof of payment, for example, an X402 payment. This is not mandatory because maybe the task is done for free, maybe you're paying the user, the agent in other ways. But we are, as a community, we are very close to the X402 community. We are very bullish on X402, and we think that this is just the beginning. And in general, payments will be a very important way to mitigate Sybil attacks, to wait feedback, to wait signals. So just to be straightforward, if an agent has done $10 million of revenues, of course, it's like in a physical company, it's more probable that the service is decent and that there is trust around the agent. And so this is the first step. It's the specific payment. The EVM can't access all the payments, but it's to, again, provide visibility, because then anyway can aggregate all this information, verify the payments, and evolve the system opinion around a given agent. In terms of validation registry, the last one, what you do as an agent, so I'm the agent and I send a validation request to a given smart contract that I decide. So each agent server decides in this specific case what's the smart contract that should validate his work. You sign what's the agent that is making the request, because why it's needed. I'm signing this as the owner, so I could have multiple agents, and so I need to specify who I'm sending the request for. Then I send the link to the payload, and that's, in this case, it's mandatory, it's not optional, because that's where the information to run the validation are. And it can be on IPFS or on centralized storage. In the latter case, I need to put an hash. If it's IPFS, I can put the CID. CID in IPFS is the content ID, so it's the unique resource locator to find the resource. And this validation is stored on chain in the memory of a contract, and then at a certain point, the validator address, and only the validator address, of course, can send a validation response, which a response integer from 0 to 100. You can use it as binary, 0 failed, 100 passed, or use the numbers before. Again, the community will do what the developers will want. The request hash is mandatory, because it's the connection to the original request. So the smart contract is saying, I received a request, which was the request hash request. It's the unique identifier of the request. This is the response. And then I have an optional information I can add in pointing to an off-chain file. Again, if I'm using IPFS, I can put the CID. If I'm using other kind of storage, I need to put the commitment to the file, which is the hash of the file. And the purpose of this is integrity. Otherwise, people could change the file afterwards. I still have a tag which is optional, but has been inserted because of different needs expressed by community. Imagine that the state of a validation can change. Soft finality, hard finality, you can use this. Before leaving the stage to Leonard, just one short thing. In the last version of 8004, clients, as I said, don't need to register, and this makes by far easier to do gas-sponsored feedback, because you just need a private key at the end of the day to sign a feedback, and this can really help a lot in terms of UX. So to be straightforward, you can build explorers where users can give feedback without having fund on the wallet. Or reputation is not just for explorers. You can use it again. It's, as I was saying at the beginning, is signals among agents. So you can use them in the specific application logic. So for example, I'm playing with friends and creating a game based on 8004, where agents, that's agents, not people. Agents needs to collaborate among each other, form teams, so they can reconstruct words, and they can deceive, they can lie. And so in this case, the feedback is used as a way for the team members to say, oh, my team leader is a liar, I don't want to work with him anymore. So this very flexible agent, so client A says of agent B something, can really be used. It's a public signals on chain, can really use how you want. And lastly, you can also, we expect the community to index information, because if you're building a front-end application when it's to show a game, an experience, an explorer, you probably don't want to download at runtime all the information that is partly on the chain, as you have seen. And as you know, all this information is in events, and downloading events in real time. I mean, you need to, it's a very bad thing. You need to go through the blocks. Off-chain stuff even worse. So we expect indexing to happen. And based on how ETH-8004 is structured, you can use, for example, subgraphs. And we have worked with the graph community to make this straightforward. So we have a Q&A at the end, and now let's get into it more hands-on with Leonard as just released, by the way, as you were saying earlier today, the reference implementation.
Yes, thanks, Marco. So actually, before we get into it, I think maybe it makes sense to just give a quick description of how the flows work. So I'm just gonna delete this for now. But basically, the structure of the identity registry and the reputation registry, the contracts are live, so and deployed as a Sepolia already. There's a link in the chat. And there's also a link to the contracts. If you want to try it out, you can run it yourself locally using Hardhat, right? You can just do npm Hardhat tests and everything should run. But I'll just give a quick architecture overview of how things work. So at a high level, there are three registries. There's an identity registry, there's a reputation registry, and a validation registry. So there are three Solidity contracts. The first contract is where you register agent. So let's say you register your agent, you will actually be agent 0. So agent 0, you will register you could register nothing even and set the token URI, but most people will probably register with the token URI. So if we look at the contract, right, just want to bring you guys through from an implementation point of view, you can register with your token URI. And this token URI is going to be, this data is on-chain, right? But it's going to point to an off-chain JSON. And we call this the registration file. So in this case, this IPFS, this is a real one that I have that's pointing to this. So if we just open my terminal, kind of forgot. Okay, IPFS daemon, right? And then let's take this URL. Cool. So this is actually live, right? You can actually see it here. And this points to, just some endpoint, right, that I have. And this is off-chain, right? Because it's stored on IPFS. You can store it on your own server, then you have to change your URL to something like HTTPS. But the point of this is to keep this data off-chain, but then have something on-chain that links to it. And that's how you register and how you get discovered. Because once you're here, people can find you on the registry. You can find the agent ID and then get all the information, including, let's say, A2A, or if you have an MCP server, you list it here, or your agent's wallet, things like that. So that's the first step. You would register with the identity registry, right? You just register, and then you can set metadata and get metadata, but most importantly, registering it. Once you have that, we get to the reputation registry, right? And what is the reputation registry for? As the name suggests, it's for people to give feedback about your agent. So if someone interacts with your agent and they like it, they can give a score to your agent. And that score basically improves your agent's reputation. So over time, as more people rate you, hopefully get a higher score with more people using it. I'm going to put back what I saw here, what I had here. So basically, if you're a user, right, you would first go to the identity registry to find the agent. You would go get the token URI. You would retrieve this information that's off-chain, right? And then maybe you would talk to the agent. You talk to the agent at its endpoint. And you interact with the agent and you use the service. And part of the spec requires you to so look at how the spec works. Part of the spec requires you to return this thing called a feedback auth. And a feedback auth is basically a signed object. It's basically a signed object of this format. So a signed object of this format, signed by the registered agent's address. And you basically get this feedback auth token, which is basically this tuple that's signed. So you, as a user, let's walk through it again. So you're a user, you discover the agent through the identity registry. You find his token URI. You go get the off-chain data. You talk to its services. It could be A2A, MCP. The agent is required to give you back feedback auth. And then from there, once you have feedback auth, you can use this feedback auth to submit it on-chain. So that's where you basically take the feedback auth and submit feedback. And there's a bunch of rules around how the feedback works, right? You can allow the user to submit multiple feedbacks, but I would say those are details that you can look into. But most importantly, the main point to take away is that you can the agent, after the user interacts with the agent gives you back a signed token, and using the signed token, you can submit a feedback. So it has to be like that. User cannot submit feedback unless he has gotten a signed token from you. So this kind of prevents some kind of spam situations. So that's what the reputation registry is for. And of course, the reputation registry refers to the identity registry for things about the agent, like who owns it, things like that. This is kind of like a soft trust assumption in the sense that reputation is a way to see if your agent is reliable, but you can also have validations. So validations are much more provable things. So for example, things like ZK, right? TEEs, crypto economic guarantees. If you have a task that is provable and can be validated and proven, with the proof being submitted on-chain, what will happen is the user instead, right, would basically use a service once again. Oh, sorry, not use a service. The first step for this is a user would use a service actually. He will use a service, and that's the first step. It's the same, right? And you would complete a task. So the agent might complete some task, and then the agent will ask for a validation request. Right, submit validation request upon completion of the task. And then let's point to the part of the contract that has this. Yeah, so you submit a validation request, and then a third party can, let's just call them a validator. A third party can submit a validation response that corresponds to this validation request. And these are basically for more provable things. For example, if you want to submit a TEE proof and have someone else verify that you actually did your work in the TEE, then this is how you would do it. And you can submit multiple ones, but I think the main takeaway here is that validation registry is for a user to talk to the agent, and the agent has something that can be validated. The agent submits a validation request, and the validator submits a validation response. So this creates the building blocks for more complex things that can be built, but it solves the discoverability problem of agents. If you register here, people can go to the identity register and look at the information you have. And also through these two registries, it solves some of the issues around trust. So this gives you a way to get reputation. This gives you a way to validate what they've done. So I won't go too much into the actual contracts because they're there to read and they're quite long. But I think what I'll do is maybe just give you guys a sense of how to run this yourself so you can play with it. So you can go to ERC-8004. It's already linked in the chat. You're gonna have to do things like npm-i and the basic things to get it started. I think a lot of people here in the call are developers, so I'm sure you'll be able to figure it out. If not, you can ask Claude. It always helps. And what you can do is do npm run local. That'll run a local hard hat node with the default keys. And then in a separate repository, let's make this a bit bigger. You can npm run deploy. And this will deploy the contracts here. There are variations on the deployments. There's deployments with upgradability, there are deployments with vanity addresses. You can look through the npm scripts just to see what's there, right? But there's also npm tests, so you can just run that as well to see some of the tests that are in there, to see what you can do and what you cannot do, just to get a sense. Also, out of the box, I think, I'm not sure if Marco mentioned it just now, but out of the box, ERC-8004 supports EIP-1271, which is basically signatures from smart contract wallets, which means it's entirely possible to make the whole experience gasless. So as an agent, as a person who is trying to develop an agent, you might not even need to use gas. You can do it in a gasless way and interact with all the registries. Yeah. What else? What else is in here that I think would be cool to see? I think that's about it. Okay, so that's from the contract point of view. It's already deployed on Sepolia. OX8004A. So this is the identity registry. You guys can go take a look. You can register here, I think. Yeah. Yeah, I'm gonna have to see exactly what's here, but basically that's kind of the overview of the contracts. There's also some, I would say, community developed SDKs to interact with it. So Chaos Chain has their own toolkit, I think, for interacting with their
Yes, we
for
posted
interacting
the
with
links in a
oh, it's
pinned
also
message
linked
in our
there.
community.
Yes. So I'll just copy over. So for people who want to play with it.
And please stay in the group because we will update this message, adding all the community tooling. But
Exactly.
we just
Exactly,
received
yeah.
a notification 20 minutes ago related to Teas, so for a new
Yep.
SDK. So it's very like exciting because people are literally building in public and in real time. So every day something changes in a good sense.
But if you want to try it out, there's also a couple of tests that I've written in my own implementation of the wrapper to talk to these contracts that deploy it. So you can take a look at the tests as well as examples. We can test what other test identity. So this is running against my local deployed version. So you can also take a look at some of the tests there just to get a sense of what are the things you can do with reputation, right? They are pretty comprehensive. It shows you also how to aggregate scores, how to revoke feedback, and more advanced things like that, as well as validations. Yeah, so do check it out. If you want to build on it, feel free, just to extend it, fork it, or build your own if that's what you want to do. So I'll stop here. Does anyone have any questions? Okay, someone asked a question in the chat. How does validation work? How is data privacy preserved when an agent asks for external validator to verify its work? So to answer that question, basically the spec doesn't define, doesn't dictate I wouldn't say define, it defines a way to do validation, but then dictate how you want to do it. So we leave it to teams. Like for example, there are a lot of good teams out there like File Network, building TEEs. We leave it to teams to decide how they want to do validations, and there's ways to do it in a privacy preserving way. What we've done from the ERC-8004, what we've done is to create a standard to make it possible for people to talk about validations in a structured way, so that everyone can read the interfaces easily. Okay, another question.
If I
Is
can
the
jump, sorry,
validation?
if I can add
Go ahead.
something on this on privacy. So as
Mhm.
Leonard said, it depends on how you implement the validation logic. But to make like specific examples, with ZKML, you can have privacy because you are proving to the smart contract the correctness of the computation, and so only the public inputs of ZKP are public, the private are private. So you can achieve privacy. With stake secured inference, which is the model that EGLayer with AVSs, EGLayer is a strong partner of 8004, is pushing for, where you have validators redoing the inference. In this case, the inputs are public and also the computation, because you need to enable the validators to redo the job. So ZKML private, stake security inference public, while for T's, it depends on how you use them. You can have like actually both. If you have
Mhm.
like T Oracle connectors that redo the job and post the attestation, it's like the stake security inference case. It need to be public, the code need to be public, the input need to be public, because you want different T's to rerun the job and post something on a contract. But you could also do different things like trusting a specific T that you have checked the code. Instead of having multiple connectors, you just have one T as a source that you trust, and all the private information can be sent to that T, and you trust the code, so you know that the information will not be leaked. Or you can just verify the public key created within the T, and you know that nobody else knows that key, with exception of the T, and you can just use the key and encrypt the payload and just directly communicate with that T, and it remains private as well. So I understand that especially for the T case is a bit complicated. You need to be like a T person and study a bit, but it was just to show that based on the models, you can have public or private data.
Yeah, 100%. From Preston Ong, is the validation request URI schema only restricted to IPFS or HTTP? So right, you can put anything as a string, right? But people have to be able to resolve it, right? So you can put any string you want, but people have to, there needs to be a standardized way to resolve it. Right now, out of the box, we are supporting IPFS and HTTP URLs. But of course, at some point, if you want to add your own schemas, for example, I'm not sure what EIP 1 schema is, but you can. We're planning to support more content addressable things like RWeave, things like that down the line. Yeah, if you have any suggestions, feel free to bring up as well. Multi-admin support. If the NFT owner is considered agent, how can they support? So there's this thing called operators in the identity registry. So you can already add operators there. So operators will be able to basically do all the things that an owner can do. So that kind of solves the problem. If you want to, you can add more people as operators. Yeah.
Oh, yeah. I got a question. So we already have the reference implementation for the registry, and the registries are singleton on each network. So who will deploy the the contract on Ethereum mainnet, Ethereum Foundation, or your team or whoever?
I can take this one. So it's very important in general to have singletons, because that's at the base of the 2004. And so we will for sure, in terms of not having multiple ones, like enforce the role of Ethereum Foundation to make this happen. And so we expect that 8004 team, and especially Ethereum Foundation, to act as a coordinator and facilitator of the deployments, also potentially on other L1s and other L2s, to have just one. This is a different thing from the security topic of who will control the keys of the proxy contract, because maybe in the future it will become immutable, but at the beginning we want to keep some flexibility on updating the contracts. And we don't want in any way the 8004 team or not even Ethereum Foundation to control the keys. So we will have a distributed governance with a multi-sig with different organizations. We are discussing right now how exactly this multi-sig will look like. EF is like facilitating this, but nobody will be able to like sign autonomously in production. While in testing, that's different. We're just playing with that, and we're currently using our keys.
Cool. Yeah. By the way, so what's the expected time to deploy on mainnet? Is this audited or still in progress, the contract?
The timeline is end of October, worst case, we hope. It also depends on the feedback that we receive. We just published the reference implementation today. If like in a few days, all the community members are very excited and convinced, we could also decide to accelerate this. We just want to make sure that we deploy something solid, and we like to test and build in public. So the specs are out, the reference implementation are out, and as soon as we are ready, we will go to mainnet as well.
Cool. Yeah. Thank you. So any questions, you can raise your hand and open mic if you want to. Anyone?
Yes, I have a question.
Yeah.
Mm.
Yeah, I'm wondering, since agent has a reputation and it's based on the rating from the users, it looks reasonable, but is there any mechanism to filter like the malicious like rating or like attacks?
Yes, so you can filter it. You can filter it. And I think right now it's almost, I would say it's really difficult to build a very foolproof spam slash like malicious, like filtering and malicious things on chain. So basically a lot of it will have to be done off chain for filtering. And we expect teams to eventually build solutions around that, also potentially maintaining a blacklist, of people who are malicious and have contributed a lot to spam. But yes, it's possible to filter it, yeah.
Yeah, thanks. Another question is like all the data, now like a lot of, not all, but a lot of data are stored off chain now. Are you considering to involve like the DAS?
So DAS is one solution, but I think there are a lot of ready solutions out there, like the teams like the Graph, they can help a lot of indexing. But yes, indexing solutions will definitely be very important. This will be even more crucial once we talk about multiple registries across different chains. Like for example, there's one on Solana, Ethereum, right? You want to have like a consolidated view. So I think indexing solutions are very important. DAS is a potential option also. But right now I think the Graph is something that will just work right out of the box. Yeah.
Yeah, okay, thanks a lot.
Yeah. Cool. I saw there is a
So
question in
yeah.
the comment. Yeah.
So is there only one registration and all the agents register? Or everyone can make a registration by themselves. So the goal of ERC-8004 is to have a singleton per chain, but of course nobody can stop you if you make your own registry. We just hope others won't. And preferably the chain itself will point people to a canonical, well-known singleton. But if you want to deploy your own, nobody can stop you. And I also expect that aggregators will kind of prioritize basically the most well-known singletons and registries. So over time, the community will settle on how to read from these different registries.
Yeah. Because due to limited time, so we can only have one more questions. And before that, I would highly recommend you to join the community if you haven't joined. So we are over 700 people or even more. Oh, nearly 750. So that's quite a lot. Yeah. So feel free to join and continue the question or discussions. Okay. I saw Preston. You can open your mic.
All right. Can you guys hear me?
Yeah.
Yes.
Yeah, so
Yes,
I
Preston.
kind of just wanted to build up on the question that I was asking earlier. So I understand that there's currently like a debate to decide between how much data we're putting on chain versus off chain. So that's why I was asking about the EIP 155 schema earlier. So specifically on the validation registry part, I was thinking that if I were to have a TE verification done on chain, what I was thinking is that we could basically put the response to the request fully on chain. So you could think something like EAS attestation, for example, right? So,
Hmm.
so I was thinking like
Right.
instead of having IPFS URL pointing to IPFS, you could basically point to the address of the registry and then maybe like the hash or the attestation ID. I believe that's what you're using to identify the full attestation result. So I'm thinking like if you're gonna point a response to an on-chain data, what would be like the appropriate way to do it, if that makes sense?
Yeah, I think that's a great use case. Yeah. We haven't fully fleshed out how that would work. Or I mean, Marco, maybe you've heard from other teams that are working on this. But yeah, this is a great. I think this is a great angle to improve on, and yeah, the
Yes,
schema thing could solve it. Yeah, it's just
in terms
expensive.
of
I guess that's the biggest problem.
I mean,
we are
like,
keeping it very generalized. Sorry, the payload of the request is off chain, but we don't mandate the data that you send to the validating smart contracts. You can like send a full attestation and do full, and that's totally doable. It's up to how you create the smart contract. In the T specific case, I think we are discussing a lot with all the T teams involved in the community. There are like three approaches. The less gas efficient, which is you literally put everything, the entire request and the attestation on chain, and you verify the attestation on chain. That's doable. Then something in the middle is you have, as I was saying, a trusted T oracle, and you just verify the signature of that T oracle because the attestation verification is done by the T oracle. The lighter option is that you just verify for the T that you want to verify the key without going through a trusted oracle. And then you have like that's what we would like to achieve actually, a public registry of T verified public key, that you can be sure that as far as you trust the code and the vendor, you can be sure that that key has been generated within the T, but nobody has access to that, and you can talk to that agent using that key. It's like a public address book of T verified keys. That's I think the direction that we are working on. But the standardization, as you were asking, of how to handle this on chain is not trivial. In T's, you have a concept of quote, raw quote, which is a very like a big field, the byte field with hashes, and we are discussing with the community how to make this happen. It's could be opinionated. It's pretty complex, and so we like separated that from 8004. Maybe we will do another standard of this. Maybe we'll just um, implementation. But by the way, if you're technical on this and you want to contribute on help, just reach out to us, because we will have meetings in the next few weeks to discuss this.
Yeah, cool. Thank you. Thank you, guys. I think that's pretty much it for today's session. We're gonna have more later in the next week, maybe. So yeah, I saw there's another question, so maybe I'll forward it to the community. So feel free to join us and continue the discussion. And thank you, Marco and Leonard, to join us today. Yeah, thank you.
Thank everybody. Feel free to
Thank
reach out.
you. Thank you.
Yeah, thank you.
Looking
Cheers.
forward to see
Bye.
what you will build. Bye bye.
Yeah, yeah. See you in the community.